In this lesson, we are continuing with series and sequences, and today we're looking at a geometric sequence. A geometric row is a row where the ratio between consecutive terms stays constant. That means that term 2 divided by term 1 will be the same as term 3 divided by term 2, term 4 divided by term 3, and you can continue like this. A reminder that an arithmetic sequence has a constant difference. That means term 3 minus term 2 will be the same as term 2 minus term 1. If you have a look at this example, 4, 12, 36, 108, you will see that term 2 divided by term 1, 12 divided by 4 is 3, and the same goes for term 3 divided by term 2, 36 divided by 12 is once again 3. And this constant ratio, we add a new symbol to, and we call it R. So the constant ratio is R. Now let's see what a geometric sequence's general term will look like. If we have a look at our example, clearly our first term is 4. If we now write our second term in terms of the first term, it will be 4, which we then multiply by 3. Term 3, we will start with the first term again, and now we'll multiply by 3 twice, so we can write that as 4 times 3 to the power of 2. For term 4, we start off the same. We have 4 times 3 times 3, and now we times by another 3. So that's 4 times 3 to the power of 3. Now, if you have a look at the pattern, you will see that term 2, we had 1 3 that we multiplied with. For term 3, we multiplied by 2 3s, and for term 4, we had 3 of them. So if we now try and write down the pattern for any number in this term, we will start off with 4 again, and we'll multiply it by 3. But now how many 3s? Exactly 1 less than the number of the term. So this is the general formula for this specific example. If we have a look at a general formula, we will start off with the first term, which is a, and multiply that by the constant ratio to the power of n minus 1. Again, a reminder about an arithmetic sequence. There the general formula was Tn is equal to a plus n minus 1 that you multiply with d, the constant difference. And now we have a constant ratio. Let's have a look at a few examples. Example 1. Consider the following geometric row. 2, 6, 18. Now, when you do calculations on series and sequences, it helps if you start off with writing what you already know. We know that the first term, which is a, is 2 in this case. It's a geometric row, so we can go and calculate R, the constant ratio, which is term 2 divided by term 1, or term 3 divided by term 2, and in this case that will be 3. Now the first question, determine the general term of this row. We've now actually calculated everything, so we can write down Tn is equal to a times r to the power of n minus 1. That's our general term. And in this case, a is 2 and r is 3. And that is our answer. In B, they ask us to calculate the 8th term of the row. So we are going to substitute 8 into n's place. And if you now simplify, you will get 2 times 3 to the power of 7, which will be 4,374. Now in C, they say which term in this row is equal to 1,458. So that means they are now giving us the value of the term. So this time we are going to substitute that into Tn's place. And we are going to have to solve n. Now, when you need to solve n in the exponent, we need to start off by getting rid of the times by 2. So we are going to start off by dividing by 2 on the left. And that will give us on the left, we have 729. Now, because n is in the exponent, we need to get the bases on each side the same. So the base number on the right is 3. So we are going to rewrite 729 as 3 to the power of 6. If you did not know that, you can always use your calculator's factor button. Now we can say that the exponent on the left has to be the same as the exponent on the right. And that means that n is 6 plus 1. And n will then be 7. Example 2. Consider the geometric sequence 12 minus 6, 3, and it continues up to minus 3 over 2048. Once again, we start off writing what we know. We know that a, our first term, is 12. We can also go and calculate our constant ratio by saying term 2 divided by term 1, and that will give us minus a half. Now, when the constant ratio is negative, the sign of the terms will alternate. So we're starting with a positive, then negative, positive, negative, and it will continue like that. So let's now have a look at the first question. Determine the general term. Once again, we've now done all the calculations and just go and write down the answer. Normally it's a times r to the power of n minus 1. So in our case, it will be 12 times negative a half to the power of n minus 1. It's always safer to put the r value in a bracket, especially if it's a fraction or has a minus. In B, they now ask us calculate the value of the sixth term. So once again, we're going to substitute n with 6. So it's going to be 12 times minus a half to the power of 6 minus 1. You can do that on your calculator immediately, and that will give you minus 3 over 8. In question C, they ask us how many terms there are. And they can ask us that because they've given us the value of the last term. We are going to start off by substituting the minus 3 over 2048 in place of Tn. And then once again, we need to solve n. So to solve n, we're going to start off dividing by 12. Now, once we've divided by 12, we'll be left with minus 1 over 8,192. Now we need to get the base numbers the same again. So on the right, we have a base number of minus a half. So on the left, we need a base number of minus a half. You won't be able to use your calculator to get the prime factors of minus 1 over 8,192, but we already know that the numerator should be minus 1, so we can simply use our calculators to get the prime factors of 8,192, and that will be 13. Minus 1 to the power of 13 says minus 1. So now, because the base numbers are the same, we can say the exponent on the left has to be equal to the exponent on the right, which means n will be 13 plus 1. So in the end, n is 14. In example 3, we are given the first 3 abstract terms of a geometric sequence. And they ask us to calculate the possible value or values for x to make this geometric sequence. Now, because we know it is geometric, we know term 2 divided by term 1 will be the same as term 3 divided by term 2. And if you know that, the rest is all algebra. Now we're going to substitute in. Term 2 is 3x plus 1, and we are going to divide that by term 1, which is x plus 2. That should be equal to term 3 divided by term 2. And now, because we have fractions, we want to get rid of the denominators. Now on the left, we have a denominator of x plus 2. It is divided on the left. So we are going to multiply by that on the right. And similar, on the right, we have 3x plus 1 that we are dividing by. So on the left, we are going to multiply by 3x plus 1. And now we need to go and multiply or simplify those brackets. So we're going to multiply the 3x and the 1 with everything in the second bracket, giving us 9x squared plus 3x plus 3x plus 1. And same thing goes for the right hand side. So that's 7x squared plus 14x minus 1x minus 2. And now you'll see that you have a quadratic equation, which means we need to get every single term on one side equal to 0. So we'll have 9x squared minus 7x squared gives us 2x squared. On the left we have 6x. On the right we have 13x. So 6 minus 13x will give us minus 7x. And then we have 1 plus the 2 will give us 3. Now we need to factorize that trinomial. So we'll use the factors of 2x squared, which will be 2x times 1x, along with the factors of 3, which we need to use minus 1 and minus 3. You can quickly check yourself. That will give me minus 1x and minus 6x, and added together it will give me the middle term of minus 7x. So that means two possible answers. 2x minus 1 can be 0, or x minus 3 can be 0. So x is either half or x is 3.